Hi, everyone, and welcome to episode 2 of the Tracerco podcast. How are you doing, Bill? We made it to episode 2.
I'm doing great. Episode 2. Here we go.
Yeah,
Not bad.
and amazingly, we've got some questions from episode 1 as well.
We have fans. Awesome.
Well, I'm not sure if the fans are critics yet, but we do have people that listen. Yeah. Are you happy to field a couple of questions?
Come on, bring them. Let's go.
All right. So the first one is related to what's the largest column we have or could scan? And I'll give you a bit of trivia to start off as well. The largest tower was installed in Nigeria last year, and that was, you're going to have to do some quick conversions here to change the units, but that was 112 meters tall and just over 14 meters wide. So I'll give you a second to convert it to feet.
Well, you didn't tell me you had to do math. Hang on. Give me a second. Wow, 367 feet?
Big, right? Yeah.
Oh my God, that's huge.
There's actually some good footage on YouTube of it being transported and installed. But yeah, it's big. But yeah, I guess although we've not scanned that column yet, we do scan ones of varying dimensions, don't we? And I guess the thing to say is that our guys are really experienced in adjusting the technique and optimizing what we're doing on site with the various dimensions and sizes of columns.
Oh yeah, I think if I'm correct, I know here in the U.S. they've scanned towers that are just over a little bit over 200 feet. So that's still, that's a lot of climbing right there for 200 feet. Good night.
All right, great. So question number 2 was, how long does a grid scan usually take, and when is the data ready to analyze?
Man, we get this question all the time, Rob. It's a little bit tricky, right? It all depends on the height of the tower. It all depends on, weather conditions. How fast can we get into your plant, right? If you include that as part of how long it takes from start to finish. If I had to take a wild stab at this, with the data complete and everything, I would say between maybe 2.5 hours in that range we're on site.
Yeah, great. And that's really, I think that's really quick. It's great that we can be there on the morning of day 1, and you can almost have the data or some data ready to look at by lunchtime or the afternoon. So it's a same day service, really, isn't it? We don't have to go away and analyze the data or come up with any reports. We can give you data on the day to analyze and to think about diagnosing the problem. And also, if we need to, we can scan again, or we can adjust the technique, or we can look at something in a bit more detail and really be there to assist our customers with the interpretation of the data.
Absolutely.
All right, great. Well, maybe we'll just have a quick recap of what we talked about last time, and then we'll go on to a different case study for today. So what we were talking about last time was mainly the gamma scanning technique, and we said it was similar to an X-ray or a CT scan in the way that it works, but it's applied to distillation towers. Initially, the information it gives you is related to the conditions of the internals, but then we can then go a step deeper, and we can start looking at things like maldistribution, flooding, foaming, and various other problems that could be affecting the performance of the tower and the quality of the product. In particular, we looked at how adding the PackView density scale enables us to diagnose the exact issue in the tower, because we know the dry packing density, and in many cases we also know the process fluid density. So helps us to figure out exactly what's happening in the tower. Anything to add on that, Bill, from last week?
No, just the only thing I would add is that for folks that didn't get to hear the first podcast, it's called a True Grid scan. And it's one of the quickest, fastest, and easiest techniques that we have in our suite of products and services that we can use to diagnose what's going on inside of your pack bed tower.
All right, great. So we'll move on to look at a different case study today. This one's the managing wash bed case study that's available on the website. We were looking last time mainly at distillation towers, but today we're going to have a look at the crude unit, and specifically the wash bed packing within the crude unit. So we're right at the start of the process. The wash bed doesn't normally get much attention if it's working well, but it's an important thing to manage during the cycle, isn't it, Bill?
Yeah, and to your point, what they're trying to manage here is the fouling, right? They're trying to manage what's building up inside that. Normally, when we go out and scan these in the crude units, we're looking at the heavy vacuum gas oil. is where what all of our customers are trying to manage. And typically, way with this, the technique that we use in this type of situation to manage the fouling or the buildup inside your wash bed is essentially we use a technique called a through vision. If everyone's out there is familiar with what a CT scan does, we all know it takes this little thin slice and takes a look what's going on inside based on that thin slice in your body. Well, we do the same concept, so we take a 3-inch slice and we come back and represent it as like a topographical colored map. Uh, the darker the color, the more dense, that area of the wash bed is, and the more lighter color it is, the more you have free flowing liquid. There's hardly any coke buildup in that section.
Yeah, and I guess one of the differentiating factors between our other techniques here is that we're looking at a specific vertical elevation, aren't we? So we're getting, rather than a map that we talked about last time across the whole elevation of the tower, we're focusing on this elevation where the packing is, aren't we?
Correct. Right. And the good thing about that is you're looking at the same section over and over again. What most customers have us do, and I think you've alluded to it a little bit before, is the fact that when we start these type of programs, we start off with the wash bed completely clean, nothing's happened yet. It's gonna be nice and bright blue. And then as we move forward, sometimes customers want to come out once a quarter, once every 6 months, once a year. And from that point, we take the same elevation over and over again, and they can compare from, quarter, 6 months, or to a year, or whatever their program is. And from there, they can actually manage the growth of the fouling at that point, and they can adjust their operating parameters, or better yet, they optimize the process to make it better and more efficient for them.
Yeah. Yeah, and I guess the interesting thing in this example is what they're doing is regarding the packing as a consumable. So they're kind of accepting that they're going to get the best yield of HVGO, they're going to get a lot of coking, and they're going to have to manage that. They're going to use up all of the packing, but they accept that it's going to be a consumable, and it's all about managing how it's used up throughout that cycle. So the two questions that they're trying to answer here really is, what process variables can we manipulate, and what technique can we use to monitor the coking? And really where we come in is that perfect technique to monitor the coking over time, isn't it?
Yeah, and like you said before, it's about optimizing their technique, right? We have the solution to come in and monitor it for you, and we can give you our thoughts and what's going on inside there. But at the same time, it's all about helping the customer manage and optimize their process to get the more bang for their buck and the most out of that tower before they have to come to a turnaround and swap out that bed.
Yeah. Okay. All right. Well, just to go into a bit more detail about what the customer actually did in this case study, we carried out a baseline scan at the start of the run. If you look in the case study, you can see the tomograms that Bill mentioned there, and the color and heat maps. So the first scan is really entirely blue, so that's your sort of baseline. What we then did was take out a scan every 3 months, and we looked at the heat maps. You can see that it starts to build up areas of green, orange, and red, and that's the increased density and the increased coking. The first thing they tried was a very aggressive operating cycle, and they found that the lifetime of the packing was extremely compromised. So that really wasn't going to work out for them because it would bring the shutdown forward in the cycle. So the next thing they tried was more of a mild set of conditions, which the packing wasn't consumed, but the yield of HVGO was compromised. So really, what the goal of this case study is to show how they change the parameters and maximize the yield and the lifetime of that packing throughout the cycle. So I think it was 5 years, wasn't it, this particular cycle?
Yeah. Like to your point, it's all about optimization, right? Helping our customers perfect their technique in order to get the maximum life out of their wash bed. Plain and simple.
Yeah. Cool. All right. Well, I don't have anything else to say, really. I think it's a good example of selecting the correct technique for the particular problem, and showing how we can monitor the problem over time and help our customers to maximize the yield of product, really. So yeah, anything else to add today, Bill?
No, not really. If you'd like to learn more about this and actually download this case study from us, go to our website at www.tracercode.com. If you'd like to speak to Rob and I directly, you can catch us on LinkedIn. Other than that, Rob, have a great day.
All right. Thanks, guys. See you next time.
Bye.